All right, chapter 3.3, justifying parallel lines. How can I justify that lines are parallel? By using properties of parallel lines. So it's actually not going to be too bad, especially if yesterday's stuff wasn't too bad for you on these types of angles. Corresponding angles, alternate interior angles, alternate exterior angles. You might remember that when we had parallel lines, if we knew the lines were parallel, then those types of angles were congruent, right? So corresponding angles were like this one and this one, both in the same corner. Those are both in the upper right-hand corner. If the lines are parallel, those are going to be equal. If the lines are parallel, alternate interior angles are going to be equal, like this one and this one. Those are alternate interior. And if the lines are parallel, alternate exterior angles are equal, like this one and this one. So, turns out it works the other way around too. If you know you've got those types of angles equal to each other, then the lines are parallel. So, if you know corresponding angles are congruent, the lines are parallel. If you know alternate interior angles are congruent, the lines are parallel. If you know alternate exterior angles are congruent, the lines are parallel. So if you're asked to find if a pair of lines are parallel, look for those angles and see if they're congruent. If they are, you know the lines are parallel. So today's homework is going to ask you to justify things like that. So like here's an example. You're going to be asked to justify that the lines are parallel, not just say they are, because all these problems are on parallel lines. So yeah, obviously they're parallel. So for example, one there, you got line A and line B. The answer to this is definitely A is parallel to B. Don't forget that's the symbol for parallel there. But that's not going to be enough. You need to say why you know it's true. So why do I know they're parallel? Well, I'm given that those angles are congruent and those angles have a special name. Those are corresponding angles. So for this problem, I know A is parallel to B because corresponding angles are congruent. That's why I know it. So today's lesson is all about telling that lines are parallel and saying they're parallel. A is parallel to B, and then why. In that particular case, because corresponding angles are congruent. Right below here, I have another example. Again, it's pretty clear that these are the parallel lines. So A is parallel to B because, all right, I'm given that these angles are congruent. What type of angles are those? You could guessed alternate exterior, you're right. So in this case, A is parallel to B because alternate exterior angles are congruent. You can feel free to write that out, alternate exterior angles. If you want to use that shortcut with the abbreviation, right, alternate exterior angles, go for it. So A is parallel to B because alternate exterior angles are congruent. That's all there is to it. Saying which lines are parallel and why. We're going to run through just a couple more examples and then this video is going to be done. It'll be pretty quick. Those ones. A is parallel to B because those types of angles, those are alternate interior angles. Alternate interior angles are congruent. Again, feel free to use that abbreviation AIA for alternate interior angles. That's just fine. All right, let's run through on to a couple of examples that are a little bit harder. Number 5, which lines are parallel if angle 1 is congruent to angle 2? So here it looks like these are parallel in pink, and it looks like those are parallel in green, but I don't know they're parallel. They might be just a little bit off. All I know for sure is that angle 1 is equal to angle 2. Well, angle 1 is right here, angle 2 is right there. You'll notice that angle 2 is made by these two lines. Angle 1 is created by these two lines. And so if I look at those, I know angle 1 and 2 are equal. Those are called corresponding angles, right? These are both, that's the upper right-hand corner. So that since they're corresponding angles, they're going to make this line and this line parallel, A and B. L and M might be parallel, right? This one and this one, they might be parallel, but I don't know that for sure. Maybe M is perfectly flat and maybe L just tilts upward just a little bit. So it's not quite parallel. I just don't know. But I do know, because angle 1 and angle 2 are the same, I do know that A and B are parallel. So those are definitely parallel lines. So it sometimes helps to show the two lines that are getting crossed by that transversal. Remember, this line here is called a transversal. All right, so for this case, A is parallel to B because corresponding angles are congruent. And again, I use that abbreviation CA for corresponding angles. That's just fine. All right. Okay, so here's our last example for this video. For this problem, I'm being asked to find the value of x for which A is parallel to B. So I'm not asked to justify if A is parallel to B. I'm just saying, hey, what does x need to be in order to make them parallel? So this is more like yesterday's work, where if I know the lines are parallel, I know something about these two angles. So again, you kind of want to identify what you know about those angles, and then set up the equation so you can solve it. In this particular case, those are alternate interior angles, and I knew if line A and B were parallel, I know those alternate interior angles should be equal. So that's what we write. We set them equal to each other. If the lines were parallel, 3x plus 11 would have to be equal to 71. We just solved that to find the value of x where this needs to be true. All right, so as always with algebra, you get rid of things you don't like. I don't like that plus 11 there because I want the x's by itself. So I'm going to do the opposite of adding 11. I'm going to subtract 11. When I do that, the 11s go away, right? Plus 11 and minus 11 are opposites. I end up with 3x by itself equals 60. I need to get rid of that 3, so I'm going to divide each side by 3 because the opposite of multiplying by 3 is dividing by 3. Those 3's go away. You get x by itself is whatever 60 divided by 3 is. 60 divided by 3 is 20. So x would have to be 20 in order to make those lines parallel. All right, that's all there is to it. Give these problems a shot. Assignment 3.3, 7 through 9, and 12 through 15. Please, if you have questions, ask. We'll work on it together in class probably. You could also see me during my office hour. See you later.